Here is a solution to question 2 from the week 10 lab exercises. Over in eViews, I've opened up the data file, and part A of this question requires us to estimate two different models using this data. The first one I will estimate by choosing quick, estimate equation. The model has wage as the dependent variable, then an intercept constant, education as the first explanatory variable, experience as the second, and a dummy variable female as the third. This dummy variable takes the value of 1 if the person whose wage we're looking at is female, and 0 if they're male. Now I'll estimate that equation. There it is there. The question asks us to save this as model 1, so I will do so by pressing name and calling it model 1. The second model I'll estimate now. This one has ln wage as the dependent variable, so in eViews I'll specify that as log wage. Then this needs to be regressed on an intercept constant and the same variables as the original model. Okay, and I'll name this one as model 2. So that is part A completed. Part B says which of these two models appears to fit the data best. Now, these two models have the same number of explanatory variables, 3, so it's reasonable for us to compare their R-squared values. And if you look at the R-squareds, there is a slightly better fit for this log wage model, the second one that we estimated, but we have to be wary that in these two models we've estimated we have a different dependent variable, and hence these two R-squared figures are not directly comparable. In order to make them comparable, I am going to do some manipulation of this second model and calculate something called the generalized R-squared figure. To do it, I'm going to estimate y values, so estimate the wage level for each element in the sample. So I'll do that by pressing estimate. I'll do that by pressing forecast. This menu asks me, do I want to forecast wages or the log of wages? I really want to forecast wages. And it's going to create a new series for me and call it wage F. I'm happy with that, as well as all the other default options here. So I do that, and it produces this output. I'm just going to return to the ordinary estimation output, and then back underneath here I have the work file window. And you can see that this new series has been created with wage F. That's the forecast wages using model 2. To calculate the generalized R-square for model 2, what I'm going to do is go up into the command window and say at COR. This is the command for calculating the correlation coefficient in eViews. Then I need to specify which series I want to calculate the correlation coefficient for. So that will be for wage, which I'll type in here, and the forecast wages or predicted wages based on model 2. That will give me the correlation coefficient between those two things. To get a generalized R-squared, I need to raise it to the power of 2. And I'll get that result by pressing enter now. And the figure appears down here in the bottom ribbon. It's saying the value is 0.22844, and that value can be compared meaningfully to the R-squared value that we got for the first fully linear equation. So I'll flick over here. We're comparing that number to the 0.228, and it seems that Model 2 had a slight advantage, or a slightly better fit to the data than Model 1. I'll document that in the written solutions and also the answer to Part C there as well.